for absolute beginners like me. We're going to look at two problems today. One is Project Euler question 1, where you have to find the sum of all multiples of 3 or 5 in all of the whole numbers below 100. So there's the answer. It's a correct answer. And what is this madness code? So we're going to take a look at that. And the second one that we'll look at, taken from the Uiua Discord, is write code to produce what we call an outer matrix. So all zeros and ones, but it's just ones forming a picture frame. All right, so we'll take these one little bit at a time. But first of all, what is Uiua? So Uiua follows the tradition of array languages like APL, J, and BQN. And the thing that these have in common is that they use glyphs, right? So they use pictures instead of function names. J is a bit different, more ASCII based, but APL and PQN have, they look like hieroglyphics, but also most importantly, they work on arrays, whole arrays at a time. So you can do things like, here's an array, so 5, 4, okay. And then if I wanted to add 1 or add 3 to everything, I don't need to use map or anything like that. It just naturally works on whole arrays. And I could add one whole array to the other, and that's no problem. And if they miss the shape, then that's then that will be picked up as an error. Okay, so array-based languages are primed for working on arrays. The other tradition is stack-based languages, which I know very little about, but I think the classic one is called Forth, and there's another one I've heard of called Joy. And so the thing here is we don't write things like 4 plus 5 and get an answer. We put 5 on the stack, we put 4 on the stack, and then we call the function plus, and we get the answer. Right? So I like working down the screen, but then once you've got the idea, then you can do this, right? So plus 5, 4, you read it right to left, so this puts 4 on the stack, then it puts 5 on the stack, and then it calls the add function. So something else like just mucking around before, if we say hi and there, so now the top of the stack is there, and the second one is, second on the stack is high. So the output down here shows the stack, and but although we call it the top of the stack, because that's where you pop values off, it's written in a more readable format. So what can we do? Well, we can duplicate a value on the stack, right? So with dot, that duplicates the top of the stack. If we use comma instead, then that pulls the one behind it and puts a duplicate on there. And another important thing is the colon, which flips the top 2 things on the stack. So if I put a couple of other 5 things there, then you can see 5, 4 high there, but if we put a colon, then that just flips the top 2 things. So that's important if you need to call a function on 2 arguments, but they're in the wrong order. Okay, one more thing. If it's semicolon, it just drops the top of the stack without doing anything. Another cool thing, like just a really cool thing that I'm not going to be using, is a thing called dip. Now dip, if I say I want to, well, let's just say I want to reverse, so that reverses the thing on the top of the stack. But if I call dip reverse, then it dips into the second level of the stack and does it there instead. Okay, so it's just, I've never had a use for dip because I've never done anything complicated, but I guess I did want to just show a couple of other cool things. So hi there, if I were to join them, then it just makes, if I wanted to couple them, then now couple, if if I can show what couple does, 54 and 19 and then couple, then it makes an array out of 19 and 54. Okay, now I want to make an array out of high and there, but I can't because they're not the same length. See, these are not really strings, they're actually arrays, and couple only works when they're the same length, right? So this gives us an error, but what you can do is you can say, I'm going to fill that with the space character, and now, so fill is a modifier. It modifies the way this function, the couple function works, to say I want you to fill it with a space character. Okay, so so now I've got that on the stack. So notice that the high and the there have been consumed, and now the stack has only one thing in it, which is a result of that coupling. So now I have a two-dimensional array. If I ask for the shape of the array, then it's got two rows and 6 columns. So what are some cool things I can do? If I rotate it, then it'll, no, okay, so that didn't work, and I'm not going to think about why. I can transpose it, and look how cute that is. The transpose glyph is sort of coloured up like a trans flag or something. It's really cool. So I've transposed the array so it goes down instead of across. I can add 1 to everything. So you can add 1 to letters, and you just get the next letter. So interestingly, the next letter after space is exclamation mark in the ASCII table. I can reverse the array so they go in the different order. But what if I wanted to? And also I can make a copy and then reverse, so I get to see the original and the transformed one. Right? I might get rid of the +1 just so. Oops. The +1, just so it's a bit more readable. We've got there, high, and then we've got high and there. So I've reversed them. But what I can do instead, so back to here, what if I want to reverse there and I want to reverse high? So what I need to do there is call a row reverse. So this says apply it to every row instead of to every element, and then apply the reverse function to every. Okay, so anyway, all good fun. All right, now on to Euler 1. So if we've got the numbers 1, 2, 3, 4, 5, 6, 7, and we want to filter only the things that are a multiple of 3 or 5, and then we want to add them up, so then we would get 14. All right, so but we would need to do that to all of the numbers 1 up to 999. Okay, so I'm going to start by doing a range 1000. Now, unfortunately, well, a cool thing about Uiua is that it's designed to make it easy to output graphics and sound. And if it thinks you've done something that's graphical or sound in nature, then it will interpret it that way. If I just go up to 100, probably better anyway. So I'll just do this up to 100, and then we'll calculate 1000 at the end. So I've got 0 to 99, right? That'll do me nicely. And now I'm going to say, well, if I take the mod 3 of all of that, then I get 0, 1, 2, 0, 1, 2, and I'm interested in things that equal 0. And so that gives me a true and false for where they equal 0, right? So 0, 1, 2, 0, 1, 2, 0, 1, 2. I think you can see that going range 100, and by the way, these are all the glyphs, and if you roll over them, you get a brief description, and if you you can click them to see, command click them to see proper documentation. If I go range 100, I get 0 to 99. How about I drop 1, and now I've got 1 to 99, which fits the problem description a bit better. So now if I go mod 3, I get 1, 2, 0, 1, 2, 0, and if I say where does that equal 0? Then there we go. All right. Now I want to do mod 5. I want to say equals 0 mod 5, but I've got a problem. Well, it's not that I have a problem so much, but I'd now be, if I do equals 0 mod 5, I'm not acting on the original, I'm acting on what I had there. So what I'm going to do is I'm going to say say D for data equals say drop 1 of that, and then I'll go okay, and so now I've got two things on the stack. One which is a mask for everything that's 0 mod 3, and one that's a mask for everything that's 0 mod 5. And what I can do is I want to OR those together, okay, but OR doesn't exist. None of the logical things exist, or maybe one does, but OR does not exist. What we'll do is we'll take the maximum because it's equivalent. All right, so now I've max takes a maximum of 2 arrays, so I acted on the 2 arrays that were on the stack. We take the maximum, and now we've got the zeros and the 3s and the 5 combined. Now what I can do is I can, if I do a where, then it will tell me what indices the ones occur at. So if I put a dot there, I can see the original. So the first one occurs at index 2, then 4, then 5, and so on. And now, for the sake of my actual solution, I need to remove this drop 1, because now, see this 1 corresponds to a 0. We're going to add all of these up, because that's the problem. I need to add all these up. And so these need to be correct numbers, don't they? All right, so the where gets the indices where the array values are not equal to 0. And now I can simply do a reduce sum and get the sum of that. So that adds up everything. And that dot was only so we could see it. So there's the answer. And if I make it 1,000 instead, then there's the answer, which is the correct answer for Project Euler number 1. Now, there's some refinement to be done here. We assigned a variable here, and that's nice. Like, this is like, you know, when you're used to other languages, it's elegant. You assign intermediate values to a variable and then you use them and so on. The spirit of a stack-based language is different though. And whether you like that spirit or not, it's definitely worth engaging with it for a different way of thinking. So what we're going to do here is not do any assignment at all. Now this is just not going to work because we run out of stack. So I take 1,000, right? And then I do equals 0 mod 3. And a little hack here, if I show the stack, and then I get an error because there's nothing there, but at least I get to see what's on the stack there. So this is like to me, it's like a print and exit. Anyway, so I've got the 0 mod 3. Now I want a 0 mod 5 of the same thing. Well, what I really want then is I need to put a dot. So I'm going to actually kind of start this from scratch, right? So here we go again. All right, so 0 mod 3. So now I need a duplication of that because I need access to this array if I'm going to do a 0 mod 5. And now I need to do a 0 mod 5. Well, I need to flip them so that I can do a 0 mod 5 on that. And so that now I have both of what I need and the rest is the same. I take the maximum and I can do a where and I can do a reduce sum. Okay. Now it literally just occurred to me for the first time that instead of doing a flip, I could do a dip. And that's ironic because I said I've never used it before and I don't expect to, but I think I can actually do a dip here. I might need brackets to say what the scope of the dip is, there we go. So I was able to dip into the stack and do a 0 mod 5. So no flipping necessary. I think I like that more, but it's sort of neither here nor there. Okay, so that's kind of explained that much code, right? Because you can put it on one line. So I think a normal way people maybe is, oops, I keep saying take when I'm in range. So I've got my range 100, and then I'm going to duplicate it, and then I'm going to go equals 0 mod 3, and then I'm going to flip, and then I'm going to, see, this is the same as working down the page, but it's working right to left because the interpreter works right to left. And so then equals 0 mod 5, and then take the maximum and then do the where, and then do the reduce sum. Okay, and so what we can do here is I can make this a function. So I can say Euler1 equals, now unknown identifier Euler, right? So I thought I'd be able to, all right, okay. Looks like you can't use the numbers in a variable name. All right, well, that's unfortunate. So I'm going to call it Euler1. Now, so there's nothing on the stack, but if I go Euler1, then I get the answer. But what if I want, the point is, like, if I take that away, then I've now got a genuine function that I can provide a number to. So there's the answer for the actual Project Euler website. What if I want to go up to, okay, so if I want to go up to any number I like, then there we go. One thing I don't know how to do is to, say, apply it to that, right? Now, actually, I shouldn't have done that because that actually does mean something to Uiua, but it doesn't, I don't really know what it means. Now, there's an execution limit of 2 seconds, so hopefully it's going to finish gracefully here. Or maybe if I can just run it again, there we go. All right, so Euler1 with input 1000, and I get that answer. Now, something occurred to me just before making the video. So if I start with range 100 and okay, so here's like the expanded solution, right? Now, there's a slight issue with this, right? So I'm operating on that, and strictly speaking, I'm operating on that, but the 0 doesn't affect the result. What if I changed the problem and I wanted to actually operate on, say, 75, 76, 77, all the way up to, let's say, 200? How do I get that? Well, there are 126 numbers there. So if I go range 126 and then I add 75, then I've now given myself those numbers. What if I want all of the, what if I want the mod 3, mod 5 sum of this? That's not going to work very well. So to demonstrate, oops, can't delete that, silly me. To demonstrate, let's say we take 100, but we add 50. Now, I get the same answer, 2282, whether I add 50 or not. So, so let's see why that is. So I get those two things. Now the plus 50 makes a difference here, right? Okay, because I'm operating on different things. So that the code's good so far. And then when I take the max, then that's good. It's combined the mod 3 and the mod 5. The problem now is the where, because look what it gives me. These are the things I'm going to be adding up, but these are indexes into that, right? I don't want the indices into this array. I need to now take them out of the original array, which is this, right? I need to take out numbers from there. So instead of doing a where, which like it works for the Project Euler problem, but it only works because we're dealing with the first 100 or the first 1000 natural numbers. But if we shift them up 50, it doesn't work anymore. So what I need to do now, right? So getting the sum of those is not useful. So what I want is I want to keep. Now, if I just demonstrate, we ignore that value. If I want to say keep and okay, so that didn't work too well. Bit surprised. Select, okay, so I've selected, maybe if I make this a bit, okay, so 4, I've index 4 is C, index 2 is G, so that's what I'm, selecting from here. So that's called select, right? Well, so I kind of want to select using these indices into the original list, but I can't do that because I run out of stack, right? Without that, there's only one item on the stack, but select needs to consume 2 items. So it needs to select, the indices from the, actually I'm going to demonstrate. So I'm going to say D equals that, right? And then I'm going to pop D back on the stack and see I can get D back here, right? And then these are the indices. So I equals that, and if I go select ID, no, that didn't work. Okay, all right. I'm not going to... It's something I saw just before recording. I wish I could include it here, but I'm not going to try and problem solve while recording. Okay, on to the next thing. This is really, really cool. So the challenge was put... what is a small and clear or whatever bit of code that will produce an outer matrix? So like I'm not good enough at Uiua to actually read this and understand it. That's a gross understatement. And so to actually gain some understanding, we go through it one little bit at a time. So we'll start by doing range 5. Right, so that's this bit, and then equals 0 applies a mask, so it's a Boolean now, so it's true, false, 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 false. And now the next thing we could do, I'm going to ignore the dot for now. This is to take the maximum, but then that's not much good. What's happening here is that there's a cross, right? Apply a function to each combination of the rows of 2 arrays. So I need to demonstrate actually. We could do it at times tables, right? I think. So if I do a n equals, let's say +1 range 12. So I've got 1 to 12. And if I make a times table, so I'd go cross and then apply the multiplication function to n and n, then we've now got a times tables, right? And the multiplication can be different things, like it can be join, and that is a legitimate thing, but it just shows every pair. If I make this say 3, then we've got 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and see if I replace that with the times, then I'm going to get 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and so on, right? So yeah, we're doing so here we're doing an each maximum. So what we've got so far is this. So we're going to cross this with itself. Therefore, we need a dot because we need 2 arrays. We're going to cross it with itself. So if I go cross, and it's taking the maximum, and it gives us that. Now, it takes a little bit of thinking to see why that's the result. If I did plus instead, then you just get a 2 up there because you got 1 plus 1. But anyway, take the maximum. All right, what's next? Well, now it's going to do a reverse. So that gives us the bottom row, because without that, without the reverse, like it's reversing the order of the rows, right? Could even do a rotate, I think. Okay, maybe not. Rotate 1. Yeah, so rotate 1 would do the effectively the same thing. All right, so, but anyway, we'll do a reverse. And now we want to do a reverse, but instead we could do a rows reverse, right? Or just row reverse. Okay, and that reverses each row. And what we want is to do both of those. So I need another copy of this, right? So I'm going to do a reverse, and then we're going. Okay, so I've got 2 copies, and then when we do a reverse, it affects only the top of the stack, and then we're going to dip into the stack to do a row reverse. Okay, so now we can see we've got 2 things. We just need to combine these, and it's simple. Combine them with max, and there we go. Okay, and so this is exactly that code, just expanded line-wise. And yeah, so on the Discord, this challenge was put up. This was the first solution posted. It's the only one I've looked at. I'm going to look at other ones and see what I can learn from how they work as well. Okay, hope you've enjoyed. See you later.